In page 438, number 33, you're trying to show that the area of square ABCD, so the area of ABCD is congruent or is equal to the area of rectangle EFGD. So you're trying to prove that those two areas are equal. Let's talk about what we know as the area of the square. That's any of the sides squared. So we're going to deal with that in a minute. So the area of the rectangle is base times height. FE times ED. So let's look at what we have here. We have some interesting things. Since FEDG is a square, I know that angle G is a right angle. Also that angle F right there is a right angle. And that FE is equal to GD. So what we also have is we have some angles congruent. I know that ED is a transversal, so that angle GDC, this angle here, is congruent to that angle there. So those triangles are congruent. So this triangle here is congruent to that triangle there. So CGD is congruent to HFE. So therefore, what we have is some interesting stuff going on. We have the fact that, and let me do some erasing here so we can see it clearly. We now know that HEDC, that is a parallelogram. That right there is a parallelogram. With the congruent area, so the area of HEDC is congruent to the area of the rectangle EFGD. So the area of that, let's look at what the area of that is. You have the base here, HE. So I have HE base times the height. Now the height is the segment that goes from the vertex of one of the sides that's perpendicular to the base, HE. DA goes from the vertex D perpendicular to the line that contains HE. So HE times DA. So that's the area of the rectangle, which equals the area. So that's the area of HED, which equals the area of the rectangle EFGD. Now, if we could get HE equal to one of the sides in the square, we would be golden. Well, it is. HE here is congruent to CD because of our congruent triangles. So therefore, HE is congruent to CD, so I have CD there. So the area of the rectangle is CD. And then also, CD is congruent to DA because it is a square, so CD times DA. Those two things are congruent, so that equals one of the sides of our square squared. So we've now proven that.